Good morning, class. Today we're going to be looking into radicals and square roots. What is a radical? A radical is really just anything that uses this symbol, the square root symbol. The number inside the symbol is the radicand. To read it, we say the square root of x or radical x. Here is the square root of 16. 16 is the radicand. We can also call it radical 16. A radical has to be simplified as much as possible to be used in quadratics. Since 16 squares evenly, we can simplify it to be 4, since the square root of 16 is 4. Now, there are a few properties of radicals. Properties simplify radicals. The first property is the product property. The square root of AB is equal to the square root of A times the square root of B. An example using the product property is the square root of 20. The number 20 can be broken down into the square root of 4 and the square root of 5. Since the square root of 4 is 2, the answer becomes 2 times the square root of 5. 5 cannot be broken down any more than it already is, so this is the final answer using the product property. Here are some practice problems. Pause the video, then come back to them after you're done. You should have completed both of the practice problems. We will now work through them. The square root of 24 can be broken down a couple of ways. We can break it down into 8 and 3, but neither of those numbers are perfect squares, so we'll have to find something else. Always try to find the simplest numbers first. We can split it into 4 and 6, and since 4 is a perfect square, we can make the problem 2 times the square root of 6. This is our final answer. Then we have the square root of 54. It can also be broken down a couple of ways. Let's try radical 9 and radical 6. Radical 9 is equal to 3, so the answer is 3 times the square root of 6. The other property used is the quotient property. The quotient property is the square root of A over B is equal to the square root of A divided by the square root of B. An example of this is the square root of 3 over 16. This becomes radical 3 over radical 16, which in turn becomes radical 3 over 4. Here are two practice problems. Pause the video, work through them, and then resume when you are ready. Time to work through these problems. The square root of 12 over 25. This becomes radical 12 over radical 25. Radical 25 can be simplified to 5. Radical 12 over 5. Are we finished? Not quite. Radical 12 can be broken down even further into radical 4 and radical 3. So our final answer is 2 times the square root of 3 over 5. Now we are finished with the problem. Remember to always simplify everything as much as possible. Before we move on to the second practice problem, here is a quick public service announcement. It is bad math manners to leave a radical in the denominator. If you do this, you will offend the entire math community, which is really bad since math is the universal language. Therefore, you'd be offending the whole world and the universe will implode. So don't do this. Instead, just multiply both the numerator and the denominator by the radical in the denominator. Now, back to that other practice problem. The square root of 2 over 15 is equal to radical 2 over radical 15. Radical 15 isn't a perfect square, sad day. But we can multiply both the top and bottom by radical 15 to get radical 30 over 15. Can the square root of 30 be broken down? Let's see. Radical 30 can't be broken down into any perfect squares either, but since it's in the numerator, it's alright. Our final answer is radical 30 over 15 since it can't be reduced any further. Next, we'll be looking into conjugates. If the denominator is in the form a plus radical b, you need to use what is called a conjugate. A conjugate, once multiplied, cancels out the denominator. In this model, the conjugate is a minus radical b. This method is called rationalizing the denominator. Here, we have 4 divided by 2 plus the square root of 5. First, we find the conjugate, which is 2 minus the square root of 5. We multiply the numerator and the denominator by the conjugate. We end up getting 4 times 2 minus the square root of 5 over 4 minus 2 times radical 5 plus 2 times radical 5 minus 5, because we use FOIL to distribute to all parts of the conjugate. The parts with 2 times radical 5 cancel out, and 4 minus 5 is negative 1. After distributing the 4 in the numerator, we get 8 minus 4 times radical 5 over negative 1. Here are 2 practice problems. Pause the video, work through them, then come back when you're ready. Alright, you should have finished the problems. In the first problem, you may have noticed that there is a radical in the numerator. Don't worry, this is okay. We can still solve the problem. Rationalize the denominator by multiplying it and the numerator by the conjugate, 1 plus the square root of 2. This makes the numerator radical 3 times 1 plus radical 2 and the denominator 1 minus radical 2 plus radical 2 minus 2. Remember to distribute the whole conjugate. In the final answer, you can leave the numerator as is or distribute to get radical 3 plus radical 6. Either is accepted. All this over negative 1, the denominator. In the second problem, we have 2 divided by 9 plus the square root of 7. First, we rationalize the denominator with the conjugate, 9 minus the square root of 7. We then get 2 times 9 minus radical 7 over 81 minus radical 7 plus radical 7 minus 7.
Good grief, that's a lot of 7s.
From there, we can try to find our final answer. But try not to distribute immediately, and here's why. Our denominator ends up being 74, which is divisible by 2, so they cancel out. We end up getting 9 minus the square root of 7 divided by 37, and that is our final answer. To add or subtract radicals, you must find radicals with like terms. Think of variables. The square root of 6 and 7 times the square root of 6 both have the radicand of 6. When added together, we get 8 times the square root of 6. The square root of 7 and the square root of 3 are not like terms, so we can't add them together. So this is our final answer. Here are 2 practice problems. Pause the video, work through them, then come back when you are ready. Okay, you should have completed the practice problems. We will now work through them. In the first problem, we have 6 times the square root of 3 plus 8 times the square root of 4 minus the square root of 3. First, we find the like terms. 6 times the square root of 3 minus radical 3 is 5 times the square root of 3. Then we find the remainder of the problem. The square root of 4 is 2, and 2 times 8 is 16. Our final answer is 5 times radical 3 plus 16. In the second problem, we have the square root of 5 plus 8 times radical 13 plus the square root of 20. First, we need to break down the square root of 20. 20 can be broken down into radical 4 and radical 5. Radical 4 is equal to just 2. Radical 20 is 2 times the square root of 5. Our overall problem is now the square root of 5 plus 8 times the square root of 13 plus 2 times the square root of 5. We add the like terms together to get 3 times radical 5 plus 8 times radical 13. This is our final answer. Alright, bear with me. We have one last topic to cover. Now we're going over solving quadratic equations using square roots. In quadratic equations, we are trying to find x, where the parabola crosses the x-axis. In many cases, the parabola crosses the x-axis twice. In other cases, the parabola merely rests upon the x-axis. Sometimes it's nowhere near the x-axis. All of these are acceptable solutions. Solutions can also be called roots, zeros, because y equals 0, and x-intercepts. Quadratics are usually in the form ax squared plus bx plus c equals 0. But when in the form ax squared plus c, they can be solved using square roots. Remember that the caret symbol means squared. This is the only time we can use the square root method, when there is no bx. We make the equation ax squared plus c equals 0 because we're finding the zeros. An example of this is x squared equals 4. We find the square root on both sides. X squared can only equal x, and 4 squared is 2. Our final answer is x equals positive or negative 2. Why the positive or negative? Because 2 squared equals 4, and negative 2 squared also equals 4. It can be either. Don't forget this. Here are 2 practice problems. You know what to do. Alright, let's work through these. First, we have 3x squared equals 27. First, divide by 3 to get x squared by itself. Now we have x squared equals 9. When you get the square root of both sides, you find that x equals positive or negative 3. In the second problem, we have 2x squared plus 7 equals 47. First, subtract 7 from both sides to get 2x squared equals 40. Then, we divide by 2 on both sides to get x squared equals 20. Find the square root on both sides to get x equals positive or negative radical 20, which can be simplified to radical 4 times radical 5. In the end, we find that x equals positive or negative 2 times radical 5. This is our final answer. And that concludes our lesson on radicals and square roots. Be sure to practice radicals and square roots often to get good at them. I hope this lesson was helpful, and if it was, feel free to like the video or comment. See ya, Hannah Renee.